This is our new topic mm, on SIMATIC HMI in TIA Portal. In this topic, we will explore the function of the slider and IO field for analog value processing. You can see in this slider we have the chance to select from 0 to 27,648. This is the range for the analog value. You can see that when we reach to the max, the escape value is 100. When we are reducing and reaching the minimum value, we will reach to the 0, and if we go negative, we will receive a scaling error. This is the purpose. There is a safety purpose behind this option. When we have under range or over range, we will select the safest value. In this case, that we are scaling temperature value from an analog card, analog module. The maximum escape value will be considered as the output. And you can see that even if we are in the normal range, the output remains the safe value, and the operator should press the reset to return to the normal value. So in case of error, and if the cause of error is gone, your operator intervention is crucial. We want to create this project, and we are using S7-300 and SIMATIC HMI. We will develop the program in TIA Portal in ladder, and we will use SIMATIC HMI to create the user interface. I will explain the procedure to develop the program and develop this screen. So we are back, and we will develop the program. I just delete the program, and I want to recreate the program again. For scaling, the first the first network is about scaling from conversion folder in the basic instructions. We need to select the scale. The input of this block is a slider. This is the value that we will receive from the HMI, the min and max values, and the bipolar. For the bipolar, we need to create some bit here, bipolar, and it's Boolean. And in order to have false input, it's possible to make the same to put the same signal in series. So the bipolar signal is always false. We will add return value. The return value is in word format, and we need the output in real format. So the return is in word format, it's okay, and the output is in real format. So scaling part is finished. We received the data from a slider in 0 to 27,648. We received the slider, the value from a slider. Consider that the value is coming from the analog input, and we will scale that based on these high and low limit. The next step, check if scaling okay. For checking the scaling procedure, we need to compare for equality. If the return value is 0, if return value is 0, this is the normal case. We save this this signal. Set. Okay, signal is Boolean, and here let me see if it's possible to add a move function when we have this. When the return value is 0, it means that the condition is okay. And we will copy the output of the scaling output to the actual output. The actual output is the temperature indication in the HMI, but in case of having any trouble, if OK is not true, it means that we have a trouble here, and in this case we will move $100, the safe value, to temp. So in case of we have this OK signal is not true, it means that we have overrange and underrange. In this case, we select the upper safest value. It's also possible to consider I want set prior flip-flop, set prior flip-flop. For the set prior flip-flop, we need the reset signal. Reset signal is coming from HMI, and set is prior in order to trigger the alarm. I just negate the OK signal. When the OK signal is false, I need this alarm, and for the alarm we have a memory. This alarm is crucial for us when we have this alarm we use S prior. In S prior, this in case of the validity of set signal, and when the set signal is true, and at the same time you have the reset signal, the output will be true, and it's the best case to use them for alarm. For overrange, underrange, and error, in this case, we need to create a branch. It's an OR logic. In the OR logic, we combine the not negated OK signal with the alarm in both of them. If we have alarm, or if the OK signal is not true, the max value, safe value, will be written. And in here we also need to have the negated version of alarm. If alarm is 0, the actual value can be transferred to the indication in the HMI. So I think the most part of the programming is done. The next step will be creating the graphic page. For graphic page, it's advisable to make a copy of all elements in the PLC and go to the HMI and copy those tags. So in this case, we have those tags. In HMI, we go to screens, the router screen. In the router screen, we create the elements. The first element, we need to insert the slider from the library, the elements library in SIMATIC HMI editor. For this, we need to change the max and mean value. This is the max value for analog input in SIMATIC technology. The mean is 0, and the process tag will be the slider integer value. This is the slider. The next step will be adding a button to reset, the reset button. Right click on the button in events. We have press and release. When we press, we try to set a bit, and the bit that it's important for us to manipulate in this case is the reset bit. When we set this bit in release, we need to reset that. Same signal, and save. So the button is also added. We need I field. right click in properties, go to the properties, first change the format, and the tag related to this I field is the temp, the unlock, the floating point value. Let me change the format again. You can add the decimal point. The type of data, the mode is output. We just have the indication. And let me change in text format. It's possible to increase the text related to this. It's also possible to increase the text related to this button. And I think we are done with the reset button and the IO field. IO field is very crucial. You need to indicate and show the process values from transmitters and the result of operation, result of calculation. If you want to show the result of calculation, or if you want to show any analog value from the field, IO field is very important, and you can use these IO fields to apply the set points from the operator to the machine. The final task will be adding the scaling error. Scaling error. I need to change the sizing of this text format 25, and the color. For color, I think appearance, text color red. Yeah, and we want to let me change the size 25, 30, 30. So for a scaling error, you want to change the visibility. In visibility, we should go to animation, visibility, and in the visibility, if you have the alarm, this text should be visible from 1 to 1. So if you have the alarm, this signal is visible. This text is visible, and also we will work on the dynamic color and flashing. Let's see, we have the same binary signal. If we have this, we'll test. The flashing is true. If the signal is 1, when the alarm is true, we have the flashing. So I think the task is done, and we will function test. The HMI is online now. It's possible to change. When we are in the max, we have 0. We are in the mean. We are in the mean we have 0, and in the max we have 100. In middle is the middle is around 13,000 or 14,000. You can see in the we should go to the ladder program. If you go online, no problem is in the program processing. We should go online. So we are in online mode. Let me download the program. So in the online mode, the return value is 0. There is no error, and we are happy. So we want to create the error. In order to create the error, we should change the mean value to the negative number. The mean value of a slider, we change that to minus 5 and run the project again. So when we have the negative value, it's somehow like the under range in a real transmitter. So we are in the positive case, we have the positive values, and in the negative case, this is the safety of the system. It means that in the negative analog input, we have under range, and we decide to report the max value. So if we solve the under range case and we have a normal value, consider we have 50% here, but the process value is still the max, the safety signal. We have the temperature transmitter and the safety signal is 100. We need to reset, and the analog processing will be back to normal. So operator intervention is very important here. It's also possible to change the max value. Let me change that and see the result. You can test that in your program and see the result. This is the over range. Yeah, it's possible to go to the ladder program. You see that in the ladder program the return value is non-zero, so something is wrong happening. So this is the over range. If we are back to normal, we need to reset, and the normal analog reading is done. Our a new topic related to safety analog input processing is finished. We used a slider and a I field to demonstrate these tasks, and I hope you find something new in this topic, and please subscribe to our YouTube channel. Thank you for watching.